We're going to see in this video what are the feature maps, how we can get them, and how we can display them with Keras. Hi, welcome to this new video. I'm Sergio, I'm a computer vision consultant, developer and course instructor, and I help companies, freelancers and students to easily and efficiently build computer vision software. Before continuing with the lesson, I want to let you know that I have also another lesson. It's a crash course called Computer Vision Blueprint, where we're going to get very practical to build computer vision projects, and you will understand and learn how to detect and track any object in the most efficient and fastest way, even if you're a beginner. pysource.com/blueprint, link down below in the description. Also, all the free source code that I'm going to release today about this lesson, you can find them. There will be another link, just scroll to the link in the description, you'll get all of them. Now back to the lesson. I'm going right away with the code, and let's talk about feature maps. The feature maps are what we get as a result from the convolutional layer. We saw in the previous lesson the convolutional layer, where we use that to extract features, and the feature map is the result of the features that we extract from that layer. Now, I don't want to mix too much talking with theory. We're going step by step because everything will make more sense when we see that in real life. To make things very smooth, I'm going now to create the model quickly with Keras. I suggest to use the same image that I have. So you have this image, you can download the image from the link below. Now let's import Keras. Now let's load the image, cv2.im. I forgot to import cv2, which is OpenCV. Let's import cv2. So the image img equals cv2.im read. We want to load the image dog.jpg. Dog.jpg. Now let's make sure that we're loading the image correctly. cv2.im show. So let's display this image. So we display the image. What's the title? Let's call this just EMG. What do we want to display? We want to display EMG. Now await key event to keep the image on hold. cv2.wait key 0. I'm going now very fast because I repeat this in each video that I make. So I'm going very fast with this for that reason. But when we will get to the feature maps, we will slow down a bit and see things with more calm. This is the image. We have the image. Let's now create the model. Again, you should be familiar with creating a model because we saw that in previous videos. Model. So model equals keras.sequential. Now we're going to create the first and only layer that we're going to use, and we're going to use the convolutional layer, which is the same that we created in the previous video. Model.add. What do we want to add? We want to add the convolutional layer. So let's now import the layers from Keras. From Keras, we're going to import layers. Let's now create the first layer of our network, of our model, and we say layers dot conv2d, so the convolutional layer. Let's now define the parameters of this layer. So we start from the input shape because that is going to take the image. So it's going to take this dog image. Now regarding input shape, let's define ourselves a size of the image. So we don't want to use the full size image because usually we don't do that with computer vision and models that we use, but usually we shrink all the images to a standard size. Each model has its own size. We can now use, and it's a square. Now to start, we can use, so you see now this image, it's quite big. Now let's shrink this to a predefined size of 2024 by 2024 pixels only. So what we do is we shrink the image, emg equals cv2.resize. So whatever image you have, it doesn't matter, all the images are going to get the same size before we pass them to the model. cv2.resize, and we want to resize what? We want to resize EMG, and we are going to make EMG with size of 224 by 224. Even if your image is a rectangle, is not a square, we're going to resize that to a square. So that's the standard that we use in computer vision. You are going to lose some proportion. So if it's a wide and you shrink it, it will lose the proportion, but that's how it works. So don't worry even if you're going to lose the proportions. 224 by 224. And let's load now this image in grayscale format. cv2.im read grayscale. So we load it into grayscale, we resize the image, and now we want to load here the image. So the input shape is going to be 224, 224, and 1. 1 because it has only one channel at the moment. 224 width, 224 height, one channel because we have only one color so far. Let's now add the layers. Layers equals comma layers equals, let's say 64, and then kernel size equals 3 by 3. So nothing new, we saw this in the previous video, but it's good that you repeat this to get practice with this. Now that we have this, we displayed previously what we get from the convolutional layer. Now we want, instead of going inside, like displaying the convolutional layer, we want to pass the image to the model to get some output, some result from this image. So what we are going to do, we are going to get feature maps, or let's say that it will be the result now. Let's say feature maps, feature map, let's say feature map equals model dot predict, and now we want to pass the image inside the model. So the model is going to take the image and just give the output of the last layer. We have only one layer, so the output will be a feature map from this layer right here. And it's going to be, we need to put the EMG right here. But remember, before we pass the EMG, there needs to be some preprocessing. So we need to convert the EMG into a NumPy array, import NumPy as np, np.array, and instead of giving EMG, we want to put this inside brackets. Why do we put this inside brackets? Because model.predicts is going to take multiple inputs. So in case we pass multiple images together in other videos, for example, for the training, we'll put EMG1 and it will be EMG2, EMG3, and so on. So that's why we put this into brackets. So this should be it, just to get the feature maps. So if we don't get any errors so far and we are able to print this, it means that we did everything correctly. So we are going to run this to make sure that everything runs smoothly, and then we can, so let me pause this, so comment on cv2.wait key, so later we can display the feature map. Filters, okay, already the first mistake, instead of I don't know why I put layers here, but this is filters. So when we use the convolution layer, it's input shape, filters, and kernel size. I don't know why I put layers, but it's supposed to be filters. So let's see now this. And we already got something out of it. We see now, I just printed everything we see a lot of numbers right here. And this is our feature map. Now we need to understand how to display this feature map and what is representing. So instead of like displaying it right away, let's first unpack it and let's get a bit more understanding of what we have inside this one. So feature map, let's print feature map.shape so that we have an idea of how the array is built. If you remember from the previous video, we had something similar. So now we have 1, 222, 222, 64. So this is the result that we get. 1 is because now we pass only one image. 222 and 222 is the size of the image that we get, and 64 are the images that we get right here. So we're going now to slowly display everything. Feature maps. But now what I want to make, because instead of using OpenCV when we display such thing, it's better to use matplotlib. Matplotlib is a library that we use to plot images. Like it's the standard in Python to use that. So in the previous video I used OpenCV, but let's now switch to matplotlib. If you don't have matplotlib, you can install that. So you will go to File, Settings, you go to Project. So yeah, Project Computer Vision with Keras Python Interpreter. Then we want to add a new library. We click plus and we search for matplotlib. Here you have it, and then you just click on install package right here. I have it already, so I'm not going to make the installation again. Of course, this if you're using PyCharm. If you're using another editor, you should know based on what you're using how to make the installation. And by the way, I explained like how to use PyCharm and everything in the first video, the series Computer Vision with Keras, so everything is out there if you want to check it. From matplotlib, we're going to import pyplot as plt. That's how we can plot things. We use plt. Now let's display the feature map. To display the feature map, we need to we have 64 images because we have 64 filters, so we get 64 features. We need to loop through all of them and extract one image after the other. Let's now display just one of them, and later we will loop through everything. Let's extract feature image from this feature map. So feature img. If you remember, when we printed the shape of feature map, we had 1, 2022, 2022, 64. So feature map. Now we need to consider this as an array, and we are going to select what we want to get from that. So we had 1 was the first value because we have only one image, so we get index 0 because we want to take that one. Then we had 2022, which is the height of the image. We want everything of the height, so we put colon and comma to take everything. Then 222 is the width, again colon and comma. And then 64. We had 64 because we have 64 filters which give us 64 images. We will now display the first one, so we take index 0, and later we're going to display all of them. So let's now take feature img. Now we want to display this. So let's display this feature image with matplotlib. It's very simple. plt.imShow, and we show feature img. And now plt.show. And let's now run feature map. This is the result that we get for the first image. So if we load, for example, another, we have like 64 of these. Now what we want to do, we want to display all of them together so that it can make more sense what we get with this feature map, and we'll get more into that as well. Let me just change something with matplotlib. We want to display this in a grayscale. So cmap equals, let's say, gray. And also now we are displaying just the index 0. So if we want to display the second one, we just say index 1 right here. So if I run this one, we are going to get another image like from the second filter that we get. And we have now, this one is another one. Let's display all of them. So I'm going to stop this. And how do we display all of them? We can load of them by looping through all the filters. So we can do for I in range, we have 64 filters, so range of 64. And we get, let's leave all this inside the loop. So this I will be 0, 1 and so on till 64. So instead of 1 right here, we're going to put I, so that when we loop through that, we get all of them. But also we want to subplot the images differently. We want to, on matplotlib, we have to say, okay, put on cell 0, column 0, put the image 1, on the cell 2, like row 1, column 2, put like the second image, and so on. How do we do that? We're going to add right here a new line, ax equals plt. No, so we're now going to subplot. So we're loading the images one by one. So now when we take the first feature image, it will be placed on the position 1, the other in the position 2, and so on. We need to define 3 parameters on subplot. How many images do we want to have vertically, and how many images we want to have horizontally? Considering that we have 64 images, let's put 8 by 8, so it's balanced, so 8 vertical and 8 horizontally. And right here, we need to put the index of each single image. So when we get index 0, it's the first image. We need to say, okay, display this one in this specific position. So this is the position of, we have 64 cells generated, and we need to say, okay, put this image on cell 1, cell 2, and so on. So we put I, but matplotlib doesn't start counting from 0, but it starts counting from 1. So we say I plus 1. I hope that everything makes sense. If you're a beginner and it's hard to follow, I recommend just to split all the steps that I'm doing. So you take feature image, you show just the image singularly, and then you just run everything until it makes sense for you if you're a beginner. So don't worry if it seems hard to follow, because it's not. Feature map. Let's now run this to make sure that everything is correct right now. We display them. Just one thing that I need to change inside matplotlib. So I want to hide this number for the x and the y positions. So this is going to, it's saying like about the pixels. So from, we have 0 to 2022, 0 to 2022. Let's remove these numbers, and then let's run this again. So ax dot x set x pix, and like this, empty, and the same for the y. And let's run this. Okay, apparently there is a typo, so like this, and let's run this again. And that's the result that we get. We see that somehow the image of the dog is changing. So each one is quite different. So how can we interpret this, and what is like the purpose of feature maps? The purpose of feature maps is to extract features, and the farther we go inside the model close to the output level, the less information we have. So the concept is, for example, if we want to, let's say, recognize a face, the face will be a series of multiple features. For example, will be the eyelashes, the mouth, the nose, some other feature of the face, and so on. So ideally, each image right here will represent something different from the face. And when we have a lot of features that make a face, then we say that's a face, otherwise it's not a face. So that's how slowly during the network close to the output level things are going to change. Now you need just to understand that each one of them is going to extract something different. So that's the main purpose, and it will be more clear when we get to other levels. So for the moment, stick with this, and later videos, when we see like full networks, for example, classification networks, when we see multiple convolutions one after the other, we will also analyze them. Now, one last thing before going further is I want to show also that we can load the image with color, not only with in grayscale. And also I want to show like what is going to change. I will start first displaying the summary of the model, model.summary, like this, and let me run this right now. The model now is taking an image, grayscale image, so only one channel, and we get on the convolutional layer, we get 640 parameters. If we enable multiple channels, so an image with color, we can do that. So instead of taking input shape with size 2024, 2024, 1, we take this with 3 channels and we load this with color. Remember always that the image is in with OpenCV in BGR format, so it corresponds like if we have 3 images. The first thing that you need to see is how significantly the parameters number increased. So we from 640 we are to 1792. This because now we have 3 channels. So depending on the model, of course, we need to have the image with colors, but also could be grayscale. So like we will get in depth later in other models. I wanted just to show you that you can get the image with color as well. If we split the image, so how is in 3 channels, BGR equals CV2.split, and we split EMG. So if we display B, we have the first channel, second and third, BGR, CV2 with key 0. Let me just show you what is an image with color so that you can grasp the difference from color and grayscale format. Now I'm representing one by one each single channel. Of course, you see that there are some differences. So this is the blue channel. So the more quantity of blue, the more you see this intense. The green channel and the red channel. All of them mixed together will give a BGR image which has the colors. This is all for this video. I hope that everything was clear. I want to remember again, pysoft.com/blueprint if you want to watch the computer vision blueprint to get practical information about object detection with OpenCV and deep learning. And all the source code that I explained and showed today is available for free. You will find another link below. You will see blog post in the description to get this one. This is all for this video. See you in the next one.